All right, let's talk about something that kind of pokes a hole in one of the biggest ideas in tech right now. This assumption that AI is just going to get exponentially better forever. But what if the very thing fueling all that growth is about to run dry?
I mean, we've all seen it, right? The pace is just insane. We're talking about AI's ability to handle really complex jobs doubling every 7 months. That is just a wild, almost unbelievable rate of progress. But here's the big what if for today's explainer. What if that incredible trend, the one we've all gotten used to, is hooked up to something that isn't infinite? What happens when the engine starts to sputter?
Okay, so let's get into it. To really get our heads around this forecast, we first have to understand how researchers are even measuring AI getting smarter. And for that, we're going to look at a key idea from a research group called METHRA. And that idea is called time horizon. Now, this isn't about speed. It's about how long an AI can stick with a complex job from beginning to end without messing up. You can almost think of it as its attention span or its ability to see a long project through to the end successfully.
And here's where it gets really interesting. If you look back from 2019 to about now, the AI's time horizon just shot up exponentially. And guess what else did? The amount of raw computing power being thrown at R&D. The two curves are almost mirror images of each other. And that right there, that brings us to the hidden engine behind this whole AI revolution. This progress didn't just pop out of nowhere, no. It was being fed by something very real, very physical, and very, very expensive.
So the core idea here is that all this progress we're seeing is basically chained to the growth of computing power, what everyone just calls compute. It's the raw horsepower, right? All those thousands of chips grinding away. For years, the simple formula has been more compute equals smarter AI. And hey, don't just take my word for it. The researchers behind this paper put it bluntly. They argue that this whole trend is pretty clearly being driven by that exponential growth in compute. It's not a coincidence, it's cause and effect. But here's where the plot thickens. According to OpenAI's own forecasts, that fire hose of compute isn't going to flow forever. After this crazy steep climb, they're predicting the growth rate is going to slow down and then start to flatten out pretty significantly as we head towards 2030. So if AI capability is tied to compute and compute growth is about to hit a wall, what happens then? Well, the researchers didn't just point this out. They actually built a model to make this connection official and to see what it predicts for the future. And their process was super straightforward. First, they looked at the trends we just saw. Then, they built a model to explain that connection. And in doing that, they found a really simple but really powerful rule. And of course, the most important part, they tested that rule on real AI models to make sure it wasn't just a fluke. And this is the golden nugget, the single most important takeaway. The rate at which AI gets better, its time horizon, isn't just kind of related to compute, it is directly proportional to the growth rate of compute. So what does directly proportional actually mean? Well, the paper spells it out perfectly. If you cut the growth rate of compute in half, guess what? The growth rate of AI's capability also gets cut in half. It's a one-to-one relationship. Simple, powerful, and a little bit worrying. So, a theory is great, but does it actually hold up in the real world? Turns out, yeah, it really does. The researchers checked by model against different AI families, like Meta's Llama and Alibaba's Qwen models, and they found the same exact pattern, a clear, predictable link between how much compute you use and how capable the model ends up being. This thing looks solid. All right, now for the really juicy part. What happens when we take this new formula and apply it to the future? What does this compute slowdown actually do to the timeline for AI progress? So you've got two roads diverging here. The old forecast is the one we thought we were on, just assuming that past performance would continue forever. But the new forecast, the one based on this model, shows a very different path, one that's tied to the realities of that compute slowdown. Let's put some real numbers on this. Let's take a super ambitious goal, an AI that can reliably handle a task that takes a whole month. Based on the old trend, we'd expect that by 2029. But the new model, it pushes that date all the way out to 2033. That's a 4-year delay. And it gets worse. What if you need that AI to be even more reliable, say 80% successful on that 1-month task? The forecasted delay just explodes to 7 years. The more you ask of the AI, the more the slowdown is going to sting. And that's really the key takeaway here. The delays aren't the same for everything. As you can see, for a kind of hard task, the delay might be a couple of years.
But as the jobs get way harder and you need them to be way more reliable, the delays just stack up and get much, much worse. So what's the bottom line here? It's this. The march of AI progress isn't magic. It's not some inevitable force of nature. It is fundamentally tied to very real, very physical things, like how many chips we can make, how much power we can generate, and how much money we can spend. And that just leaves us with this one last big question to chew on. If the biggest roadblock to smarter AI isn't just about writing cleverer code anymore, but about the brute force of building factories and power plants, has the entire game changed? Is the race for AI no longer just a software problem, but a global manufacturing and energy problem? It's definitely something to think about. Thanks for tuning in.